Welcome to Unit 5, Lesson 13, Exponential Functions with Base E, Practice Problems. Okay, the population of a town is growing exponentially and can be modeled by the equation given here. The population is measured in thousands. That's important. People forget about the units. So this 42 means 42,000. And times 0 is 1950. So this is another important number. All right. So what was the population of the town in 1950? So obviously it was 42,000. What is the approximate percent increase in the population each year? So years is the measurement. And so 0.015 times 100 is 1.5%. And then what was the population? So just stick in T for 10. So in your calculators, you're going to hit 42. Second, ln, which is next to the 4. And then a parenthesis is going to pop up. E is going to pop up when you hit these buttons. And a parenthesis is going to open up. And you're just going to type in 0.015 times 10, close the parenthesis, hit enter. And you will get the number about 48,797 rounded to the nearest whole number. Okay, let's look at this question. The revenue of a technology company in thousands of dollars can be modeled with an exponential function where T is measured in years. Okay, that's important to know. After 2010 is our initial amount. Which function predicts exactly 1.2% annual growth? Now, what you can do is do e to the 0.012, and that will give you second ln, and then 0.012. And this is 1.012 and a bunch of numbers behind it, but we're going to round it to 1. We're going to minus the 1, and this is 0.0121. So this is a little bit more. Now, 1.012 in the S equation, once you subtract your 1 for the 100%, is and multiply it by 100 is exactly 1.2%. So the S model, the discrete model, is actually exact 1.2%. And the R model, which is continuous, is a little bit more. Okay, so here's the difference between them. They have similar growth rates. The percentage is the same, because remember, this one is 100%. You subtract it out and you're left with the 0.05. This is discrete growth, so it grows only at given times. This is continuous. It grows all the time. So they both have the same percentage of growth, but so if I was to graph f of x, it would look like this, where you have to measure out each interval of time. The G graph, so this would be f of x, and this would be g of x, will give us a continuous curve. Okay, so let's look at the next question. An investment is worth $100 and grows in value 4% each year. Explain why the value of the investment after T years is given by this. So 100 is your original amount, and this is your growth rate. Once you subtract the 1 out for the $100, that's 100%. You left with 0.04, then you had to multiply it by 100, and that's how you get 4% growth. A second investment is worth 100 and grows in value by 2% each year, each half year. So same reason, 2 is 2% growth, but 2T. So that means it grows 2 times per year. 2 times in 1 year, and you divide by 2, t equals 1/2 a year. A third investment grows is worth $100 and grows in value by 4% per year, but the interest is applied continuously at every moment. The value of this investment is given by the equation. Order the investments in from slowest growing to fastest growing. So what you're going to do is put all three equations in a y equals, and we're going to compare. And I already know that the C is going to be the fastest. It's going to be C, then A, then B, but we're going to put them all in the calculator and check. Okay, when I check, at the end of 1 year, the value for C is 104.08. For A is 104, and for B is 102. And then in 10 years, Y3, C is $1 more. And in like 20 years is $3 more. So the continuous one just grows faster. The population of a country is growing exponentially, doubling every 50 years. What is the annual growth rate? So the annual growth rate is doubling. Is doubling to t over 50. So if we raise 2 to the 1/50th, that will give us so the number was actually 1.013959. The 5 pushes the 9, which pushes the 3. So 1.0140. So minus 1, you get 0.014 times it by 100, and you get 1.4% growth every year. Okay, if b is greater than 0, what is the value of log b to the 1 over b? All right, so if I was to switch this around, say b to the x is 1 over b, so x has to be -1 because b to the -1 equals 1 over b. So it doesn't matter what the number is, you just have to understand exponent laws. Okay, the expression here models the amount of radioactive substance and the sample time over decades. So what's the 5? The 5 is what we started with. So this is 5 nanograms equals start. And the 1/2 tells us it's a half-life. That's our rate. It decays by half. And we've already given a time frame. When will the sample have less than 5 nanograms of the radioactive substance? So what you're going to do is put this equation into the calculator, but instead of D, you're going to put x over 10 to measure every year. So when x is 1, that's 1 year out of 10. So we're going to do this and find when it has less than 0.5. Okay, so I'll put it in the calculator. I had to scroll down in x. When you get to 33, when x equals 33, y equals 0.5077 to 4 numbers. When x equals 34, y equals 0.4737. So when will I have less after in between 33 and 34 years. But if this was discrete, it would be at 34 years. But this is probably continuous. So now, show that only about 5 picograms of the substance will remain 1 century after the sample is measured. So what do we start? Nanogram 10 to the 9th, 10 to the 12th, which is 3 less. So this is 1,000. 1,000 is 0.001. So we want 5 thousandths, which is 0.005. So all you got to do is keep scrolling down X until Y gets down to 0.005. And we just keep scrolling down. So when X equals 99, Y equals 0.0052. When X equals 100, Y equals 0.0049. So it's very close to 100 years or 10 decades. Select all true statements about E. E is not rational, it's irrational. It's about 2.718. Okay, E is between pi, which is 3.14, and root 2, which is 1.1414. So 2.7 is in between that, so that's true. It's not exactly. This is an estimation. Remember, irrational numbers go on forever. They do not stop. They do not repeat. They do not end.